Welcome back to the Math Lounge. Now we're going to finish up with some spheres. Makes me want to get a stress ball and squeeze it, but I left my stress ball at school. I do have my model of the solar system back there, and there's the sun. It's a sphere, but I wouldn't want to squeeze it because it's made out of Legos. So I guess I've got a squishy die, not a sphere though, but okay, that's helping me. Okay, okay, better. Onward. So let's do our spheres. So a sphere is defined as the set of all points that are equidistant from a center. And here's the equation of a sphere. Basically, what you do is you take the distance formula and you square it, because who wants a square root lying around when you don't need it? So the idea here is that you have the center is H, K, and L makes the center, and then the distance from the center squared would be the radius squared. So that's why there's an r squared up there. So if you have your sphere centered at the origin, then you have just x squared plus y squared plus z squared equals r squared, which is much simpler to deal with. And so we can always hope that all of our spheres are centered at the origin. So let's go ahead and see if we can find some equations of spheres. And um, this is going to require a little bit of algebra, but you can handle this. I know you can. Anyway, we want a sphere with a center at 1, 2, 3 and a radius of 7. So that's actually quite simple. We have x minus 1 squared, y minus 2 squared, and z minus 3 squared is equal to 7 squared. And that's it. So there's number 1. Okay, let's do number 2. Number 2, a little bit harder. We want these 2 points to be at opposite sides of one of the diameters. So let me just scroll up a bit because I need some more room. So here are the 2 points that I have there. So we have -4, 5, -2. The other point is 2, 7, 1. Notice that I don't care that this may or may not be oriented properly. I mean, I could take these and start messing with them, moving them around, but it really doesn't matter if they're in the right orientation or not. I'm just going to draw them like this and be happy about it. So let me connect these by a line because it says that these are on opposite sides of the diameter, or a diameter. And a diameter is just a line that goes through the center of a circle. So the center is right here. So we need to know where the center is, and we need to know what the radius is. So let's get the center first, and then after that, we will figure out the radius. So this whole thing, this is going to sort of bulge up here. It's going to be this beautiful sphere. Okay, well, whatever. Anyway, let's get the center. The center is midway between these 2 points. And so all we have to do is average the 2 points together to figure out where the center is. So the center is going to be the midpoint of those 2 points. So here's how I'm going to do this. I'll do 2 plus -4 over 2, 7 plus 5 over 2, and 1 plus -2 over 2. So I just have to average the coordinates together. And it gives me, let's see, this is going to be -1, 1, and that's going to be -1/2. So there's my center. Now to get the radius is the distance between the center and any point on the edge of the sphere. So I'm going to choose this one because I like it better. And so let's do the distance. The radius in this case is going to be the square root of, let's see, 2 minus -1 squared plus 7 minus 1 squared plus 1 minus -0.5 squared. A little messy down there, but hopefully it's okay. So let's see, the radius is not that pretty. Oh, what do we got here? 3 squared is 9, 6 squared is 36, and 1.5 squared, oh, come on, 2.25? It's 1.5 squared. Yeah, I think that's right. Okay, so my total I'm going to have the square root of 36, 45, 47.25. Almost done. Now we just have to write down the equation of the sphere. And so the equation is going to be x minus the x value at the center. Here's the center right here. So x minus -1 squared plus y minus 1 squared plus z minus -0.5 squared is equal to this thing squared, which I can just write like that. And then I can clean this up just a little bit. And there you go. So that wasn't too bad. Well, it was bad, but it wasn't as bad as some of the things that are coming up. So you can look forward to those other things. Oh, and that's it. So, oh, no, we got one more. I got excited, but we got part 3. So let's go ahead and do part 3. So number 3 is, let's see, we have the center at 2, 2, 2. So the center is at 2, 2, 2, and it passes through the point, what is this, 1, 10, and 11. Okay, so we need a radius. We have a center. The radius will be the distance between the center and any point on the edge of the sphere. So in this case, the radius is going to be the square root of the distance between these 2 points. The square root of 2, I'm just going to talk through it. So 1 minus 2 squared, 10 minus 2 squared, and 11 minus 2 squared. So I just did the differences in my head. I think you can handle that, I hope. Anyway, we're moving on. We're going to do this. We've got 64, 65. Let's see, 65 plus 81 is 146. So close to 12 squared. Isn't that sad? See, 64 and 82. Yeah, 146. So there it is. So then we're almost done. Now we just write down our equation. It's going to be x minus 2 squared. I'm using the center here. Plus y minus 2 squared plus z minus 2 squared is equal to r squared. And so when you square r, you end up getting rid of the radical. All right, I know you're going to have questions on this. Please do bring them to class. Write them down, send me email, and I will help you as best I can. So hope you have a great week.